Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. So, John, we are finding the volume of a cylinder today. So before I talk to, the approach I learned, I just want to mention kind of what volume is. And volume is three-dimensional, and it's basically the capacity of the cylinder. We're saying if we were, say, to pour, I don't know, water or sand into the cylinder, how much could fit? How much could it hold? So the way I had learned it was, again, just to memorize the formula. The volume is pi r squared h for a cylinder. So in this case, I would say, okay, the r is given to us as 3 inches. So that's going to be 3 squared. And the h is 10 inches. That's going to be 10. And 3 squared is 9. 9 times 10 is 90. So I get 90 pi. And again, volume is three-dimensional. So it's going to be cubic inches, or inches to the third power is how we write it. So, John, what is the current approach?
So your approach is great, and again, this is the way I learned it too, just by plugging in the R and the H. But students are tasked these days with finding volumes of lots of different types of three-dimensional solids, including cylinders, prisms, pyramids, you name it. And for them, it becomes very difficult to memorize specific different formulas based on the solid. So one approach that we often use is we say that volume in general involves finding the area of the base times the height. And depending on what the base is, that B part will change. If the base is a circle, then we use pi r squared. If the base is a square, we use side squared. Like, it really just depends on what the base is and how the shape, travels. If it curves up, or if it slants up, or if it goes straight up, that'll have an impact on the overall volume formula. So with this idea in mind, this image here just basically shows that another way to think of volume is through cross sections. That if I am looking at the volume of a cylinder, I am more or less looking at a stack of circles that, we have so many of them, right? And each circle is pi r squared and as an area, and we're stacking those all up across the entire height of the cylinder. So we can think of it as a quantity, right? Like, if I have a circle area of pi r squared and it travels all the way up from bottom to top, that whole distance is h, the height. So I could also think of volume this way, as pi r squared, the area of the base, times the height. So it's like traveling all those circles up to the top. And the math that we use is identical to the math that you just used. The radius is 3 if we're assuming the same problem, and the height is 10. So this means that we're going to have lots of circles with an area of 9 pi all the way up, our 10-inch stretch of height, which gives us an area of 90 pi inches cubed. And this would be what we call an exact area, because we're not rounding, or an area in terms of pi. But if we did want to give a more approximate area, it'd be about 282.74 inches cubed.
So, two thoughts. One, the thinking of volume as base times height, that seems like almost like, a black turtleneck that goes with everything. Like, it doesn't matter what shape you're looking at, it's going to be base times height, and then you let the shape inform what the base is.
Correct.
So that seems very versatile.
Correct.
And then also, I just want to mention, I noticed that you used a slightly different equal sign for the approximate answer. That I assume is for when you are approximating. Is that correct?
Correct. So it looks a little squiggly. It's not straight lines, and that means just approximate. So I rounded to 2 places when I wrote that answer out. 90 pi is what we call an exact answer. I never rounded. If you type 90 pi into a calculator, you will get lots of decimals. But in order for me to have a finite answer, I just rounded to 2 places. So because I rounded, I lost a little bit of accuracy. So therefore, we call it an approximate answer, and the equal sign is just squiggly to show that it's approximate.
Which is a lot of fun to write, I have to say.
It is.
All right, wonderful. Well, I'm ready to find the volume of a cylinder.
All right.
Okay, so now I'm going to find the volume of a cylinder with the radius of 5 centimeters and the height of 9 centimeters. If instead they had given us a diameter, we could just cut the diameter in half, and then, it would be the exact same problem if they gave us a cylinder with a diameter of 10 centimeters. We just cut it in half, say, okay, radius is 5, and go on from there. So what I'm going to do is I'm going to remember that the volume is going to be base times height, kind of our universal formula. And then I'm going to ask myself, okay, in this case, with this shape, what is the base? And the base is a circle. And I know the area of a circle is pi r squared. And then I know the height is given right here as h. So that's how I can figure out my volume. So my radius is 5 squared. My height is 9. So I'm going to say, great. This is going to give me 5 squared is 25. And then 9 times 25 gives me 225 pi. And that is cubic centimeters. John, that's great. And the nice thing is this is going to apply no matter what my shape is. So it's kind of a way I can approach any volume problem without having to memorize the formula and then fear that I'm thinking of the wrong formula at the wrong time.
Correct. And in some videos that we'll follow up with, we'll take a look at what this looks like for prisms and pyramids and other types of shapes that follow the same approach.
Ooh, pyramids. I can't wait. Wonderful. Well, thank you everyone for watching. We hope you found this video helpful. We're Math Videos for Parents. So please follow us on Facebook and YouTube. And if you have any problem requests, don't hesitate to reach out to us. We love to help you help your kids with math.
Thank you.